Today we'll be talking about ocean acidification. So what is ocean acidification? Ocean acidification is the lowering in pH of the world's oceans by the addition of carbon dioxide from the atmosphere. It is important to note that the world's oceans are naturally slightly alkaline, and therefore acidification is causing a shift towards neutral conditions over time. So how does it work? When carbon dioxide becomes dissolved in seawater, a series of chemical reactions take place. These reactions result in a net release of hydrogen ions, in turn leading to a drop in pH of the seawater. It is thought that up to 40% of all carbon dioxide produced by humans will eventually end up dissolved in the oceans, and since the amount of carbon dioxide being produced is increasing, the rate of acidification is likely to rise. Recent estimates propose that the southern oceans are likely to drop up to 0.5 pH units by 2100, a change that would be unprecedented in the Earth's history. It has been suggested that acidification could have devastating effects on corals, the organisms responsible for building coral reefs. These ecosystems are worth up to $375 billion every year and support 93,000 different species. So how does ocean acidification impact corals? Most corals produce a hard exoskeleton through a process known as calcification. Calcification relies on the water surrounding the coral being highly saturated with calcium carbonate. Acidification leads to a reduction in calcium carbonate saturation. This in turn reduces the ability of corals to produce their vital exoskeleton. Due to acidification, the calcium carbonate saturation of the oceans will continue to drop over time. This may impact the ability of corals to replace exoskeleton lost due to erosion by seawater. This could lead to corals beginning to completely dissolve. It's possible that corals in the southern oceans could begin dissolving by the end of this century. It is also thought that acidification could increase the susceptibility of corals to bleaching. This is the process whereby algae that lives within the coral is expelled, ridding it of colour and reducing its chances of survival. So what can we do about this? Several methods of combating acidification have been proposed, one of which is the addition of bicarbonate derived from limestone to the seawater in order to raise the pH. However, this would require the mining and transportation of 20 billion tonnes of limestone per year to maintain current ocean pH levels. This would obviously create many other problems due to the removal of habitats and greenhouse gas production through mining and transportation. For this reason, this method may only be feasible on local scales. It has also been suggested that it would be possible to remove carbon dioxide directly from seawater by using a technology called bipolar membrane electrodialysis. However, this technology can be expensive and may not be carbon neutral, as it may produce more carbon dioxide through burning fossil fuels than it removes from the ocean. Whilst these methods are worth investigating, it is clear that the only feasible long-term solution to ocean acidification is the reduction of the amount of atmospheric carbon dioxide produced by humans every year. In order to avoid substantial damage, it has been suggested that we need to reduce carbon dioxide emissions by at least 50% by the year 2050. So to summarise, ocean acidification is the lowering in pH of the oceans and is caused by the dissolving of atmospheric carbon dioxide into seawater. This lowering in pH damages the ability of many corals to produce their hard calcium carbonate exoskeleton, which could have devastating consequences for corals and the ecosystems that they are vital in supporting. Whilst many solutions have been proposed, the only feasible long-term strategy is the drastic lowering in human carbon dioxide emissions. Thank you for watching.